we're going to start having shapes appear inside of polygons. So we call them inscribed. Okay. So whenever you have polygons with diagonals in them, they will create inscribed shapes. And the most common ones are going to be depicted below. So imagine you have your, this is on page 43. So this would be a regular pentagon. Okay. This only works with regular shapes. So the big shape that kind of has the smaller ones in them, it's going to be a regular pentagon. And this is going to be a regular heptagon if you count. 7, right? This is a regular heptagon. But I don't want you to fixate on whether it's a heptagon, pentagon, it doesn't really matter. What I want you to fixate on is the fact that, right, you've got your polygon and then a dashed line in there. That's what we call a diagonal. So whatever color I used to highlight diagonals here, I'm going to color it with that same color. Same when we go to the heptagon here, the dashed line represents a diagonal, just one. And that essentially cuts the polygon and creates different shapes. Okay, so for example, over here you've got your triangle. Okay. And you have your, underneath this would be a trapezoid. So you have your tri, and you have your quadrilateral, so to speak. And in particular, it's a trapezoid. I don't know if you remember trapezoids, but it's a type of quadrilateral, just like a square, a rectangle, so forth. That's a trapezoid. So that diagonal creates these two. Over here, you always count the diagonal itself, right? 1, 2, 3, 4. This is a quad, right? It's a trapezoid in particular. And you've created another shape over here. If you look at the outside of the big polygon and where the diagonal goes, this is, let's count the diagonal as well. 1, 2, 3, 4, 5. Got it? 1, 2, 3, 4, 5. This is a pentagon. Okay, I'm going to use 2 different colors again. I'm going to stick with, I used pink for quadrilateral, so I'm going to do the same thing here. And whatever other color you have. Got a purple one. Let's see if that works. So just get used to that idea that the diagonals create other shapes that are in there. Okay. Now, I want you to look carefully because I'm going to make some changes here too. I think it's going to work out better. This isosceles triangle, every single one of them is going to be isosceles. You've probably never heard of an isosceles trapezoid, but you will today. Isosceles pentagon, isosceles trapezoid, like they're always isosceles, every single one of them. And I want you to think of this A here. Look where my pencil is going to go. That's going to be this one up here. Okay. What do we call this angle where my pencil is pointing at right now? Out of the psyched ones, remember? This one is the interior angle of this big polygon here. So imagine the big polygon going all around. That is the interior angle. So I'm going to call this capital I cross out that lowercase a and just say that's an interior angle right there. I will do the same thing with the isosceles trapezoid here. So these are cutouts from my examples up here. So you know where you see these two A's here? I basically want you to think of it's these two angles up here, or if you want to look at it upside down, it's these two angles right here. These are also interior angles of that bigger polygon. So instead of lowercase a, let's make that a capital I, like that. I hope it's not too messy. If you have whiteout, maybe, I don't know. But those are, I think it's going to make it less confusing if you just put capital I, because later on I have questions where there is a lowercase a and you might mix them up. I don't want that to happen, right? So go with that. So these are the interior angles of the big polygon that they're inside of, okay? These eyes here. If you look at the isosceles pentagon, this is the very bottom one here, that A is supposed to be, watch where my pencil is going to go, okay, because I'm going to move things. This A is supposed to be this one right there. Actually, there's three interior angles that I will use. This one is not an interior angle of the big one, okay? So if you go over here to the isosceles pentagon, I want you to make the same changes. Wherever there's a lowercase a, I want you to turn that. Maybe if you cross that out and just make an I next to it, hey, that would be an idea, right? Instead of making a mess. Capital I, capital I. Okay, so let's just change that. I'm going to make those changes at lunch for my next group next year, right? To make sure those are just capital I's. I think that's going to be better. Okay, so now that we've settled that, I'm gonna look through each one of them, because I'm gonna ask you quite often to figure out like these angles here, or here, right, or there. You can tell this an isosceles because these two sides are the same. These two sides are the same. And with a pentagon, look at this. It's kind of weird, but these two sides are going to be the same, so are these, right? And that always leaves you with the base angles. The base angles here are always going to be the same, so we're going to just split them in half to figure them out, okay? So for an isosceles triangle, okay, to figure out angle B here, this is what we're going to do. We're going to take 180 degrees, no surprise because it's a triangle. We're going to subtract one interior angle, this one up top here, from 180, and then guess what? We're going to divide that in half. We're going to split. Once we take the interior up here away from 180, the remainder is going to be split in half because they're basically the same. But this is what I want you to make sure you add. I'm going to use a different color for that. A lot of students do not use brackets, or they just go 180 minus I divided by 2. Your calculator is going to first divide the I in half and then subtract because it follows BEDMAS. So you got to either hit equals here and then divide by 2, or just make sure you use brackets. Okay, so that's how you would find these ones. Don't fixate on B. Just know that whatever letter I assign to these in your questions, you're finding these two here at the bottom of your triangle. Okay. Next, if you have a trapezoid, then if you wanted to find these angles down here, you would do it the following way. What is the sum of angles in a four-sided shape? 360, right? You would subtract how many interior angles? 2. So you subtract 2 I's from it. You put that in brackets, of course. and whatever is left over, we're going to split that in half. Because remember, once you find B, you're actually finding this one and this one, right? But we need to split it in half. So that's the formula that you would use for an isosceles trapezoid. And it kind of stops after pentagon, but you could continue this pattern. To find these base angles of your isosceles pentagon, you would use this formula. B, angle B, these base angles. What's the sum of a pentagon again? We just did that not too long ago. 540. So we're going to go 540 degrees, that's all of it, minus how many interior angles? There are 3 interior angles in this scenario. Once you do that, you're going to go ahead and divide by 2 again, because you're always splitting in half. So one last thing that I want to add here, okay, that these interior angles are, they belong to the big polygon that they find themselves in, okay? So I will say this, maybe I'll just leave it there for now. I have a note here. I will add this. Yeah, I'm pretty sure this is going to work out. So obviously you're going to use I of n is equal to n minus 2 times 180 divided by n. Okay. We use the interior angle of the big polygon. Okay. So this I, once you figure it out, it goes in there if it's an isosceles triangle, or it would go in there if it's an isosceles trapezoid, or it would go in here if it's an isosceles pentagon that you find yourself with. Okay. Whatever color you use for your diagonals, folks, whatever color you use for your diagonals up there, that is technically this here. Okay? This is the diagonal. Why am I saying that? Because these formulas allow you to find the angle between the side of the big polygon that they find themselves in and the diagonal that was used to cut it. Right? That's why you use these ones for. Okay. Let's put them into practice. Okay, let's put them to the test here. So these should be on your study sheet for sure. Unless you just understand how it works and then just, you don't need a formula, you just know what to do, right? I'm not a big fan of just, here, copy the formulas, good luck, right? I want to explain why they work and when to use them and how to use them. All right, 44, here we go. I'm using these ones, so if you can have these formulas right next to you there, that would be great. Calculate the values of the indicated angles. And here it is again. These letters mean nothing to our formulas that I just gave you, okay? These are specific to this question. You got to know, okay, what do I need to do to figure them out based on my formulas here on my piece of paper? Okay, so the first thing I want you to do is focus on the big polygon here. I'm going to focus on this one here, not including the dashed line, not including the diagonals, right? So how many sides are there? 1, 2, 3, 4, 5, 6. 6 sides. That is why polygons are actually sort of beautiful, because at first you're like, I have no numbers whatsoever. All of a sudden, bingo, once you know the number of sides, you can figure out. So let's figure out angle A first. Angle A, how would we find that? It's actually n minus 2 times 180 divided by n. It is the interior angle of that big hexagon. Got it? So let's figure out A. 6 minus 2 times 180 over 6. Angle A is 4 times 180 over 6. And that is 4 times 180 divided by 6 is 120. This is the interior angle of the hexagon. So what else can we call this? Question specific, it's A, correct? In general, we call this I, right? This is actually, this one is also I at the same time. So don't forget that. We found the interior angle, that's I. All right. Let's figure out what do you want to do next. Some students would go for C, other students would go for B. It doesn't really matter. If I'm going to use my green line again, right? If you now focus on this, now you can focus on that. Keep in mind that the interior angle may or may not have been asked right off the bat. You need to find it regardless, okay? What do we have here? 1, 2, 3, 4, 5. This is a penta. And this is a triangle. Right, now we focus on that. So let's use the penta for this pentagon to figure out angle C. Let's do that. I'm going to cut this here. Angle C is going to be found by what are the degrees inside of C? Pentagon. It's 540, correct? You go 540 minus 3 i's, which I know is 120 degrees, divided by 2. Angle C, let's just take it easy here, okay? Grab your calculators maybe, and it's like, are you able to type this in? Right? So I would go 540 minus 3 times 120. That's okay to do that. I'm going to hit enter there. Show me the work here. You go 180 divided by 2, and angle C is obviously 90, right? You just found out that angle C at the bottom of the pentagon, this one right here, is 90, and so is the other one, right guys? If I go with my pencil over to this side over here, that angle is 90 also. These two are the same. Okay, some of you might need to do this, and I kind of appreciate some of you actually do it when you do parallel lines. You're like, on my study sheet, this looks like that, right? So yeah, sure, if you want to do it, right, go for it, no problem. Okay. What's so confusing about this maybe is, well, Mr. Dirksen, you gave me B in my formula, so this is throwing me off. Well, that's why I told you, don't focus on the letter, focus on what are you finding in this pentagon here. You're finding that angle right there, and that one, by the way, but I could be just saying, hey, find that one, okay, which we just did. That's 90. So let's go back. We still have one left. Okay. I'm gonna say this was my first step. This was my second step there, and I'm gonna do the third step right here. You have a choice. I will say that angle B, let's see if you can follow my logic here. Angle B, I will find that by saying, I know if you look up here, this whole thing, if you look at the highlighted, the yellow highlighted, that whole thing is 120. I know that. That's an interior angle. I'm going to subtract angle C from it. I'm going to subtract C from 120, and then I'm left with B. Okay, so angle B is 120 minus 90. Angle B is 30. Okay. Bingo. You found them all. But Mr. Dirksen, could I have used that formula you gave me? Like, if I look at my formula, this is a triangle. What's the formula there? 180 minus I divided by 2. If you did that, okay, 180 minus I divided by 2, you still get 30. So it's up to you how you want to go about it, right? Some of you may have started with a triangle, found B, subtract that from 120 to get the 90 here. It's up to you how you want to go for it. Okay. You need one more or what? You're getting it? Sort of? Okay. All right, let's do B here. I'm going to grab a highlighter right here. There's a bunch of dashed lines. I'm nice. I usually put dashed lines for something that doesn't belong to the polygon. So I'm going to focus on this one at first. That's the one I want you to focus on. Don't worry about everything else right now. So you go 1, 2, 3, 4, 5, 6, 7. N is equal to 7. That's a heptagon. All right. This is what I want you to think right away. I'm going to find the interior angle. Oh, Mr. Dirksen happens to ask me for it anyways, right? I want that anyway. So we're going to go angle X is n minus 2 times 180 over n. Angle X is 7 minus 2 times 180. This one will have decimals, by the way. So that's 5 times 180 divided by 7. It's 128.57 degrees. Okay, so bingo. This is the interior angle. I will just make a note. This is the interior angle of the heptagon. Okay, so I'll maybe just take the liberty to put a little I here. Okay, that is the interior angle as well. Okay, because I need it anyways. Happen to find it. Okay. What does the diagonal do here? Now let's focus on the diagonal. It cuts this into a trapezoid and a 1, 2, 3, 4, 5, a penta. Okay, it does both. So this is already done. We got this one. Right, that's taken care of. Let's find Z. Actually, I'm going to do this differently just so you see that it can be done. I'm going to focus on the trapezoid here. So I'm going to cut this right there. I'm going to say trapezoid here. So to find angle Y, what does the formula call me to do? It says, well, if it's a trapezoid, then the sum of interior angles inside that trapezoid would be 360 minus how many interior angles does this thing have? Well, I will actually make sure you understand, right? There are 2 interior angles of that heptagon, right? So it's 2 times 128.57. And all of that gets divided by 2. Some of you might not like this, but you could technically, I use square brackets sometimes to differentiate between the round brackets that are in there. So you go ahead and plug that in. 360 minus 2 times 128.57. That's 102.86. Divided by 2. Don't forget the divided by 2 part. I see that a lot. So this is angle Y. I've got Y taken care of. So this was step number 1, step number 2, and my third step, I'm going to find Z. How do I find angle Z? What's the whole interior angle here? The whole interior angle is 128.57. Minus, I will show that I'm going to subtract angle Y from it. Minus 51.43. $77.14. What happened there? Try that again. 77.14. There's that. Could you have started with the pentagon? Sure. If you rather do the 540 minus 3 interior angles, you get the same answer. Okay. We're not done yet. M, the fourth step. Angle M is what? Exterior angle, right? Of the big polygon. So we just go, you can use the formula 360 divided by 7 if you want, or you just go 180 minus this one. It's up to you. So 51.43 degrees. This is, I'll just say exterior angle of hepta. How do you find N? Angle N, by the way, if this is M, what's this one up here? It's also M. They're the same. This is the exterior angle here. That's the exterior angle there. It's just going to be 180 minus 2 times 51.43. And that's 77.14, which we already had somewhere. Oh yeah, Z here. That's coincidental, right? Like it doesn't always. Sometimes it does, sometimes it doesn't. Okay? So, I have lots of these, but we're not going to go too crazy here. I'm just gonna ask you to try 45 and 46, those 2 pages. Okay, there's just 2 polygons there. Let me see if, sure. That's just inscribed polygons. And so I'll give you the rest of today's class to get started, because chances are you'll keep going if you start in class. Okay. Thank you guys.